Alright, in this video we're going to do this integral. I think it's a pretty fun one. It's the square root of 1 minus x squared dx. It's just a definite interval, so no bounds. So let's write it again down here, because there's like, you can see like a glare thing. Just like a light. Let's do that. Integral squared 1 minus x squared dx. So we're going to do a substitution here. We're going to say x is equal to sine theta, and that will help us integrate this thing. So we'll say x equal to sine theta, and to change this term into a d theta so we can integrate with respect to that, we're going to take the derivative of x in this, or both sides of this equation with respect to theta. So dx d theta is equal to derivative of sine theta is cosine theta. Cosine theta. Then we're going to split up the term. It's not completely proper. Let's say dx is equal to cosine theta d theta. I'm going to write that bigger. Okay, so we'll write that down here. So integral of the square root of 1 minus, I'm going to put that sine theta because that equals sine theta, 1 minus sine theta squared times dx equal to, and the way dx is equal to cosine theta d theta times cosine theta d theta. Okay, this looks a bit difficult, so we're going to use an identity. You might know this, but cosine square root of theta plus sine square root of theta is equal to 1. So if we subtract sine theta from both sides, we can get cosine square root of theta is equal to 1 minus sine square root of theta, which is right in here. So I'll put that in there. And then we'll square root of cosine squared theta times cosine theta d theta. Okay. Cosine squared theta is square root of that. It's just cosine theta times cosine theta is cosine squared theta. So we're going to do that. Keyword integral is on the screen. Yeah. Cosine squared theta d theta. And okay, so we're going to use another identity for this. It's called the double angle identity. You know, cosine 2 theta cosine squared theta minus sine squared theta. We want this only in terms of cosine 2 theta and cosine squared theta. We don't want the sine theta. So from this thing, we can figure out that sine squared theta is 1 minus cosine squared theta. So we can say that's equal to cosine squared theta minus 1 minus cosine squared theta. Okay, and that's equal to 2 cosine squared theta minus 1. We'll write down cosine 2 theta here. Okay, we want to figure out for cosine squared theta, so just add 1 both sides and divide both sides by 2. So that means that cosine squared theta is equal to cosine 2 theta plus 1 divided by 2. Then we're going to put that into this interval. We're going to figure it out. So I'll write it down here. Integral. Okay, it looks like an interval of cosine. I'm going to split it up. Cosine 2 theta divided by 2 plus 1/2 d theta. Okay, so we're going to integrate that. Integral of cosine of 2 theta is sine of 2 theta divided by 2. And this 1/2 is just theta divided by 2. So is equal to plus c. Don't want to forget that. Sine 2 theta divided by 2 times, because there's 2 right there, divided by 4 plus theta divided by 2 plus c. Okay, there's another double angle identity we can use right here. We know that sine of 2 theta is equal to 2 cosine theta sine theta. So we're going to put that in there. So equal to, so 2 cosine theta sine theta divided by 4 is just divided by 2. So cosine theta sine divided by 2 plus theta divided by 2 plus c. Now we want to get this integral back to with respect to x because that's what we started with. So there's a sine theta right here, so we can put that in there. And so if we know that sine of theta is equal to x, we can take inverse sine of both sides. So sine inverse of sine theta is equal to sine inverse of x. Sine inverse of sine is just, of theta is just theta, and so we can figure out that theta is equal to sine inverse of x. So that sine theta is just x, so we can say x equal to x cosine theta divided by 2 plus sine inverse of x divided by 2 plus c. Now we want to get that cosine theta out of there, so to help visualize this, I'm going to draw a triangle. So right here we have theta, x, and 1. So we know that sine theta is the fx, which makes sense because sine is in a right triangle, the opposite side of the angle divided by the hypotenuse, so x over 1, so that makes sense. So we can write sine theta, I'll write this a bit lower. Sine theta is equal to x for 1. And what we want to cosine theta is equal to the adjacent side divided by 1. But we don't know what it is, so I'm going to put like I'll put an a here. A is equal to a divided by 1. So we got to figure out what a is, so we can put it back in that cosine theta. We can use this using, a squared plus b squared equals c squared for a triangle, like this is. So we know that a squared plus x squared is equal to 1 squared is 1. So a squared is equal to 1 minus x squared. And a is equal to, I'm not going to care about it being negative right here, just because it's a triangle. The square root of 1 minus x squared. So cosine theta is equal to a, which is equal to 1 minus x squared and minus x squared. So cosine theta equal to the square root of 1 minus x squared. And we can put that over there. So I'm going to write it out really quick. Equal to x square root of 1 minus x squared 2 plus inverse sine x by 2 plus c. And that is our answer. Yep, and one thing cool about this is that using this, you can figure out the area of the unit circle. So I'm just going to erase a bunch of this, just so we have more of them. So that's what this integral is. I'm gonna write that down. So integral squared minus x squared dx equal to that. So if you imagine we have the unit circle, which is x squared plus y squared equal 1. You draw that, looks like this. You want the area of that, it's going to be pi r squared, if you remember that. But if we say y squared equal to 1 minus x squared, take the square root of both sides, I'm just going to do the positive half, and we're going to multiply by 2 to find the area. So y equal to square root of 1 minus x squared, which is that term in the integral. So you can imagine the centimeter rules from x equals -1 to 1. So we're going to do 2 times that because just one time we'll just do this top part. So 2 times the integral from -1 to the square root 1 minus x squared dx. We're not going to have to figure this out right because we already know it. So we can put that in. Equal to 2 times x. 2 times x squared 1 minus x squared divided by 2 plus inverse sine x divided by 2. I don't care about the c because I'll first write it down here. Because we're just going to subtract it out in the semicolon. From -1 to 1. I'm going to distribute this 2 to leave 1 else. Equals x squared 1 minus x squared over 2. Not over 2, just rewrite that. X squared 1 minus x squared plus inverse sine of x from -1 to 1. We can plug in those ones in there. So let's do that. It's going to be 1 times the square root of 1 minus 1 squared is 0. Plus sine inverse of 1, inverse of 1, minus -1 times square root 1 minus -1 squared, which is 1, so 1 minus 1 is 0, times 0, plus sine inverse of -1. So those square roots with those zeros don't matter. So that's equal to sine inverse of 1 minus sine inverse of -1. So if we draw a unit circle, the range of inverse sine goes from -pi/2 to degrees, radians, sorry, to pi/2 radians. So inverse sine of 1 is going to be right here, which is pi/2. So that's going to be equal to pi/2 minus inverse sine of -1 is going to be right here, so that's -pi/2 minus -pi/2. So that's just 2 times pi/2 is equal to pi. Which makes sense because the area of unit circle is pi r squared. R is just 1, so it's going to be pi. That's about it.